Good morning, student. Today I am going to explain about the physics laboratory some experiment. So in this part I am going to explain about the air wedge. The first point, what is mean by air wedge? Air wedge is a experiment is used to find the thickness of extremely small size object, like a very small size wire whose diameter also going to be find out. Even you are going to find the thickness of hair. So such a minute values is going to be find out with the help of this air wedge experiment. Now how to arrange this experiment? So just to look at that diagram, how to arrange this experiment. So this air wedge experiment, this is a microscope. So microscope arrangement is a glass, 45-degree slanting glass, and this is a slit, that means source. Here we use sodium vapor lamp. From that a light is going to be come out. That light is going to be fall on this lens and is going to be parallel one, then is reflected back, reflected with the help of this inclined glass, and finally here this arrangement, here the arrangement is there, this particular place, the whatever the material whose diameter is going to be find out is placed below this part. Okay, this is arrangement. Now I saw this arrangement in separately in the demonstration. You just see here and look at this. This is this we called what? The sodium vapor lamp. That is a source. In that source we have the number of slit. That this is a slit. Here every 4 side also one slits are there. Through that slit the light is come out. So this light is used as a source in this particular experiment. Okay, next the second part I already explained. This is a microscope. So this arrangement is microscope. We called it is moving microscope. Okay, so it's going to be move. So the microscope arrangement is there. Then one glass, that means we have one glass slab, that is 2 glass slab. These 2 glass slabs are combined with the help of rubber band or even the twine. So it's going to be combined within that space. So we have one space in between the 2 that is glass slab. In that space we have the particular wire or even the hair whose diameter or thickness is going to be find out. So this is the arrangement. This arrangement is kept in this particular place. That means just below this inclined glass. You see here, this is an inclined glass, the 45-degree inclined glass. So this arrangement is going to be placed below this inclined place, so that the interference fringes will be formed. Interference, so that you know, in the 12th standard itself we studied interference fringes, nothing but the superposition of 2 or more light rays that form alternate bright and dark bands. The formation of bright and dark bands is known as, that is interference. So the interference pattern will be available in this particular glass slab. So that can be viewed with the help of this microscope, moving microscope. So here the interference fringes are there. That fringes is in the form of a line, like this dark line. You see here, in this way the fringes are formed. That can be viewed with the help of this microscope arrangement. Okay, so this is arrangement. So once again I repeat, what about the arrangement? One microscope is there. So that microscope and also source, that is a sodium vapor lamp, and 45-degree inclined one glass plate is there. Below that one, that means 2 glass slab Within that two glass slab, only if space is there, then that space, the wire whose diameter is going to be find out is placed. So this is the arrangement. So already I showed that demonstration also. Now how this is going to be worked? So after this setting of this experiment, we can focus this particular glass slab through this microscope. I already told that here the interference pattern will be formed. The pattern is in this shape that can be viewed with the help of the microscope. Now I just show that formation of this interference pattern then inside this particular glass slab through the microscope. You just see the interference pattern. So how the interference pattern is going to be formed. So this is a microscope, that is eyepiece. Through this eyepiece, when you are seeing inside, so here the image formation is there. You see the interference pattern. So interference pattern is there. The yellow color light, actually this yellow color light is sodium vapor lamp. So now see here, this is a image formation, interference pattern formation. So in such a way, the images are going to be formed. So after forming this image, we can use this, that means microscope, to fix the cross wire. You look at that cross wire, one cross wire is there, one dotted wire. That cross wire is going to be focused exactly on a particular dark line, any one line. You see, number of dark lines are there in that particular air wedge. That means this is actually air wedge formation. Number of lines are there. Any one line is focused with the help of this microscope in such a way that the cross wire is exactly coincide. Cross wire is exactly coincide the particular dark line, and the corresponding values are going to be taken. So how to calculate this, or how to find the values? You see here in this microscope, the moving microscope, two scales are there. Two scales are there. This is a scale, we called it that is Vernier scale. This is Vernier scale. Then you see this is a long scale, we called it is main scale. So when you are taking reading from this long scale, we taken as main scale reading. Then this is a Vernier scale reading or Vernier scale coincidence. So two scales are there. Two scales also horizontal one. Don't take the measurement in that vertical section, horizontal part only. So this is a main scale and this is a Vernier scale. Now how to measure the reading? So now just before I set the particular interference pattern. So after setting the interference pattern, we focus any one interference dark line exactly on that cross wire. Then immediately we see that reading. So the main scale reading, how to find the main scale reading? You see here one line is there, Vernier scale arrow mark. In Vernier scale one arrow mark is there. Just this below this arrow mark, this value is actually main scale reading. So see what about the value 1, 1.5, 1.6, 7, almost 1.7. So this 1.7 is a main scale reading, MSR. In your tabular column, one MSR, one term is there. Below that, this value is going to be tabulated. Then here is the Vernier scale. How to measure the Vernier scale reading? So here we have then 5 division. You see here, this is arrow mark. Then number 1, 2, 3, 4, then 5. That means within this 10 lines are there. Then 1 to 2, another 10 lines are there. So each line is taken as one dimension. That means 50 division is there. So from this, how the measurement is taken, you just to focus this particular vernier alone. Among the vernier lines, some 50 lines are there in this below part. Among this 50 line, any one line is exactly coincide this particular main scale reading line. Suppose 20th line is exactly coincide means the vernier coincidence is 20, that is 20 division in terms of division. Suppose 15th line coincide means 1/5. Like that, anyone line that is in the particular vernier scale is exactly coincide in that lower main scale, then that is a vernier scale coincident VSC. From this vernier scale coincident, we can measure vernier scale reading by just multiplying the particular value. That means 20 means 20 into least count. So least count of this particular that means microscope is already found out, that is very small, 0.001. That can be multiplied with this division, 20 into 0.001. So that is a vernier scale reading. So in such a way the experiment is, how the experiment is repeated. So after suppose see here this particular diagram. So in such a way the large number of dark lines are formed, that we called interference pattern. Initially the crosswire is going to be focused at any one particular line, that is taken as nth line or nth dark line. So initial measurement is already taken by fixing that crosswire in such a way. So that is nth dark ring reading. Now with the movement of this microscope, already I told this is a moving microscope. So moving microscope, so it is going to be traveling microscope, that we called traveling microscope. So with the help of this microscope, we can adjust the particular dark line. So already we measured nth dark line reading. Now we move this traveling microscope that horizontally up to, suppose this is n means, we can focus n plus 5th line. That means with the help of microscope movement, 1, 2, 3, 4, 5th. 5th line is going to be focused. So that can be find out with the moving of this microscope. Okay, so how this movement is taken place, I will explain it. So this particular point, the second reading is taken. Then n plus 10th, this particular place the crosswire is going to be coincide and the corresponding reading is taken, that is n plus 10th reading. Such a way the arrangement is going to be moved, that means microscope is going to be moved and measure the reading from n to n plus 25. So how this movement is taken place, you see here. So after taking the first reading, we can move this microscope with the help of this arrangement. See here in this side here one knob is there. With the help of this knob we can move. So if we rotate this knob, the microscope is going to be moved in one side. If we move this particular microscope in left side, means continuously move in the left side till the end of the reading. Then if we the measurement is taken by moving left side, that means anti-clockwise, mean it continuously rotated in anti-clockwise and the reading up to n plus 25. In such a way the readings are going to be measured and the values are going to be tabulated. So here you see the tabular column. So this is a tabular column where the measurement is going to be that is recorded. So see here, order of fringes. Fringes means interferent fringes. Nth fringe. That only I focused with the help of this one, first fringe. So how to fix nth fringes? No need to any panic. No need to find out nth value like that. Any one dark line. If we fix any one dark line exactly with the crosswire, that is taken as n. Then next fifth line is taken as n plus 5. Like that we select. N is our desire. We only select this nth dark line. So nth dark ring corresponding MSR, main scale reading, Vernier coincident, then Vernier scale reading. How to take Vernier scale reading? Vernier coincident into least count. Vernier coincident into least count. Here coincident is 4. So 4 into 0.001 centimeter, that is 0.004. Okay. So then we add this main scale reading and Vernier scale reading. If we add these two, then that is the total reading. So such a way the experiment is repeated. So for every time we record that main scale reading value and in Vernier scale coincident, and you can find the total reading by this calculation. So this 4 column over, then this 5th column is width of 10 fringes. How to find this width of 10 fringes? You can find this width of 10 fringes by multiplying the 10th fringes into nth fringes. N plus 10 minus n, that is 10th fringes. N plus 15 minus n plus 5, that is 10th. So the first two column is actually blanks. The other 3 only is going to be filled. This is width of 10th fringes. From that, the width of one fringe is going to be, that means width of the one dark line that is recorded in that interference pattern is going to be find out. The average of this, how to find average? Add these 4 value and divided by 4, that is average. So that is a bandwidth or fringe width. We use commonly the term bandwidth. So bandwidth beta is find out by this way. So this is a tabular column 1. Okay, then we move to the second tabular column. Second tabular column, how to find this one? So here to find the distance between the edge of the conduct and wire. So already I explained in that glass slab one wire is there. That wire is going to be focused exactly. So this is a glass, see here, this is a glass slab. So here this wire is there. The position of wire is going to be focused. The corresponding reading is taken here. Wire is going to be focused, that with the help of the cross wire. Then the corresponding main scale reading, Vernier coincident, Vernier reading, total reading. That is. Then the another one is at the edge of the contact. Edge of contact means here. The contact place, edge of contact. That is going to be focused. That reading is going to be find out here. So this distance, edge of contact, and here this distance is actually L. So L is going to be find out R1 minus R2. The difference are these two. So in such a way L is going to be find out. Okay, so how to find L? First we focus this wire and the corresponding main scale reading and Vernier coincident. Then you go find this edge value, corresponding main scale and Vernier coincident. That going to be filled in a tabular column. Then from this you can find the L by subtracting or by differentiating, just difference of this, not minus, difference. Difference is going to, so it's always positive. Okay, so beta already found out from the first tabular column. Distance between the edge of the contact and wire is also find out with the help of the second tabular column. Wavelength of the light. Here the wavelength of light is the sodium vapor lamp, which produces yellow color. Yellow color wavelength is 5893 Armstrong. This will be given in that experiment. That means in the examination time also they will give. This is a constant only. Okay, so you can substitute the value of L, then lambda divided by 2 beta. Just multiply the numerator and denominator value and just divide this numerator and denominator value. So answer is almost in this particular order, of the order of 10 power minus 5 meter or 10 power minus 4 meter. Such a very small thickness is also going to be measured with the help of this air wedge experiment. So this is a calculation part also. So by this particular experiment is going to be concluded. So you just look at the various parts once again. You see, this is a source. From this that is light yellow color light will come out, whose wavelength only given 5893 Armstrong unit. Okay. Then this arrangement actually traveling microscope, that is movable one, it's only moving ones already told. Traveling microscope arrangement is there. This part is going to be movable, it's going to be moved by manually or with the help of this arrangement, already I explained. No? So one arrangement is there, rotating arrangement is there. Then this is a 45-degree inclined glass. Below that inclined glass, that is a glass, true glass slab, that in this form. True glass slab, within this glass slab, one small gap is there. There, the wire or the whatever the image whose diameter is going to be find out is placed. Then that to be going to be tied with the help of a that is rubber band or with the help of this wire, that means twine anyway. So this is a arrangement. Then how I going? So one time I just read how to calculate, how to measure. The measurement alone once again you just see. So look at this arrow. First, how to measure this main scale reading? The arrow mark of this Vernier scale, which pointed some line. So here now it is 2.1, almost 2.2 nearly. Okay. So that is main scale reading. How to take the Vernier coincidence among this 50 line, any one line. So just that can be find out with the help of a one lens also. They will give one lens. With the help of lens you can find out, because it is a minute one, a small size one. So whose coincidence is going to be found. Whatever the coincidence may be, 20, 30 or 15, anyone. That is a Vernier scale coincidence. These two readings should be taken for every that means steps. That means nth dark fringe and n plus 5 dark fringe, n plus 10, like every time you can measure this main scale reading and Vernier scale. The values are going to be tabulated. Then the second part is by focusing that wire and also the other part edge. So that through differentiation, that is the second one, L. So by knowing these two, easily find out the thickness of the wire we used here. So this is an experiment. So by this I conclude this video. Okay, study nice. Okay.